So previously we have created this material stream natural gas feed, and the unit that we used was the temperature in degrees Celsius, the pressure was in kilopascal, and the mass flow was in kilogram per hour. Okay, so if we get closer to this one, like the temperature, we will find that it is displayed in degree Fahrenheit and also degree Celsius. So 30 degree Celsius means we are talking about 86 Fahrenheit. Also for the pressure, if we get closer to the pressure here, we will find out it is displayed in kilopascal per psi. Also for the material stream, it will be displayed in pound per hour and also kilogram per hour. The point here, instead of, so if in your case all the data given will be in psi, so if I delete this one and I have that it's 14 or maybe 14.7 or 15 psi, so here I'm going to write 15, and here from the unit I can choose the units that I have. So in this case it's psi, so psi absolute. So in this case it will be displayed in kilopascal because here we have chosen kilopascal instead of psi. So if I want to have the SI unit but I want the pressure to be displayed in psi instead of kilopascal, how to do so? Because during the creation of a simulation it will be really difficult to track the units because it will be a huge simulation. So to avoid this misconception for the pressure and displayed in psi instead of kilopascal, we are going to close this one. At the file here, we are going to click and we are going down until we reach the options. So options at the bottom. In the option, we have here the unit of measure. So I am going to choose the unit of measure, and in this case we are working with SI, but the difference is we are having the SI with different pressure units. So it will be SI, you can name it the way you want. Like in this case I'm going to copy the SI unit, so instead of being a new user it will be for YouTube sessions. Okay, and so this is the name of the unit set, or YouTube is enough. Okay, so for the YouTube it's created over here, the displayed unit. I am going to keep everything the same except for the pressure. So now I'm looking for P for pressure. It will be at the bottom over here, and for the pressure it's displayed in kilopascal. So I'm changing this one from kilopascal to psi absolute. Okay, and I don't forget to press OK to save what you have done. So now if we go to home, my unit set here will be YouTube. Okay, which means this is the unit that I'm going to use while using YouTube. Okay, and this is the natural gas feed. If I double click and open it, you'll find out that the temperature is the same, but the pressure it changes from kilopascal to psi absolute. So it will be 15, the one that I've entered at the beginning of this video. Okay, this unit, before starting any model or any simulation, just make sure that you are choosing the right unit set, because if you have chosen anything wrong, all the data will be wrong. Okay, so another important point, you can change more than one unit. Like if I go to the file and the option over here, I'm looking for the unit of measurement, and for the YouTube maybe I'm taking this back to kilopascal, because during our work we will be working in kilopascal. Our unit for the mass will be kilogram, for the degree will be Celsius. So this one is like a pure SI unit, but I am giving it a different name because I was just showing you how to change the unit operation, the unit of measurement. Okay, so now we have our unit of measurement. I'm again going to open this one and look at the worksheet. Previously we have talked about the condition. The condition, this comes from the operation team, like what is the temperature, the pressure, and the flow that we are working on. Based on the temperature and the pressure, we know the vapor fraction. So we can have the vapor fraction and the temperature, or the vapor fraction and the pressure, and our stream still be defined. But it is always recommended to have the temperature and the pressure. So for example, I know that if I have, okay, if I am going to create a water stream, so now I need to go to the properties. I want to go to the component list for, I can add another component list here, so I'm going to add another one, and this component list will be for water. So if I'm dealing with water, it will be available here. So this is like the water that goes in the pipe in your home, so this will be water. Okay, and here we have a pure component water. For the fluid package here, it's Pinker Benson. So I'm entering the simulation now. So I'm pressing F1 from the keyboard to create a material stream. So this is the water that we are really using. Okay, the water that we coming from a water tap, it's usually in the liquid phase. So in this case, the vapor to phase fraction would be equal to 0. Okay, and the temperature, assuming that the temperature is between 25 to 30, so in this case it's about 25. And the composition, if I go to the composition because I forgot, here we are using, okay, for the composition the water is not displayed here, so I need to close this one, go to back to the properties, because we haven't created a fluid package for the water. So this one from Aspen, it will be also Pinker Benson, but this one for the water, the component list water. So if we enter the simulation right now and go to the water, previously in the composition here, we have the composition of methane and ethane, because we are choosing the fluid package natural gas. So in this time, I'm choosing basis 1 or water. We can go back and rename it. And for the composition, we will be asked only about water. So the water will be 1. The composition of water is, the composition is 100% water. And here for our mass, maybe kilograms, maybe 20 kilogram per hour. So now it is solved. So what does this mean? If we are looking for a water at this temperature as a liquid phase, the pressure will be 3 kilopascal for this amount of flow. Okay, so you can simulate. So if we are looking about the air around us, we know that the composition is nitrogen and oxygen. If we are dealing with the atmospheric pressure and we want to know what is the liquid, when can we change this composition like nitrogen and oxygen into liquid, we will be looking at the phase envelope. Next in this course, we are going to talk about more about the phase envelope.